we can look at this example whereby you have been asked to simplify the block diagram that is shown below and obtain the closed loop transfer function, that is C of S over R of S. So if you are asked to do this, then you look at the rules that we've talked about, and then you look at the block diagram vis-a-vis the rules that we have talked about, and look at which rule is applicable, and then use that in order to reduce that block diagram up to the canonical form. The rule is you are supposed to reduce that particular block diagram up to the canonical form in order to obtain the closed loop transfer function or any ratio. Whenever you are asked to obtain any ratio, there is no shortcut. You have to reduce it to a canonical block diagram. And just to remind you of what a canonical block diagram is all about, we say that a canonical block diagram is a block diagram with only one forward element and one feedback element. And that is what we can use in order to obtain the transfer function. So when you are given this, like in this case, we can start by combining the blocks that are in parallel. So looking at the two blocks, there are two blocks that are in parallel. There is one for the loop, of course, and there is one for the forward element. So we can combine the two blocks that are in parallel. So in that case, what are we going to do? So the first thing is to combine the blocks in parallel. Of course, if you want to combine the blocks in parallel, then you have to redraw this. So the first rule that we are going to use is we can talk of combining the blocks in parallel. You can start by saying combining blocks in parallel. Combining blocks in parallel. So if we want to combine the blocks that are in parallel, then of course, if we combine the blocks in parallel, then the block diagram will be combining blocks in parallel, comma, the block diagram will be, so if we combine the blocks in parallel, then what will be the block diagram? So in that case, we are going to have something like that, of course that, then up there we have G1 plus G2, G1 plus G2, then it goes there, then, so we are combining this, are in parallel. These ones are again in parallel again. Then here we have the feedback was minus, because that is plus, there is plus. Then here we are going to have this block in as G3 minus G4. And then this one was simple enough. From that point you can see that you already obtained the canonical block diagram. So after obtaining the canonical block diagram, because this is the forward element, it is only one forward element, and here we only have one feedback element. So in that case, we can now obtain the transfer function. So this is just a closed loop, of which if we get a closed loop transfer function, then what we are now going to do is to use the closed loop reduction, the closed loop reduction in order to obtain the overall transfer function. So in that case, we have C of S all over R of S will be given by G all over 1 that GH, of which in this case, what is our G? Our G is going to be G1 plus G2 all over 1. Because the feedback is minus, so it becomes plus GH, that is G1 plus G2. Then that one you multiply by, again, you multiply that one by H, which is G3 minus G4. So in that case, that is what we have. So this one, you can represent it so that you have R of S as your input, then the block there as G1 plus G2 all over 1 plus G1 plus G2 into G3 minus G4. And with that, you shall have obtained your transfer function. Of course, that is C of S. So that is just a simple block diagram that has been used in order, that we can use in order to show an example on how this one can be achieved. So our second example is this. Simplify the block diagram shown below and obtain the closed loop transfer function C of S over R of S. So just like what we did before, we are also going to interrogate the rules that we had discussed earlier on how to reduce the block diagram to its canonical form. So as we interrogate the rules, we are going to start by looking at which rule are we going to use. Like in this case, we look at it, are there blocks that are in series? So we cannot say this block, and that are in series because there are summing points between them. Of course, between G1 and G2, there are two summing points, and there is also a pick-off point, so we cannot say that the blocks are in series. Again, G2 and G3, we cannot say that they are in series because there is a summing point there in between, and again, there is a pick-off point that there is a loop to H2. So in that case, we cannot use anything that we can talk of as to be in series. So we look at what else do we look at in that particular block diagram. So when we look at that particular block diagram, then we are going to look at what is it that we can talk of as to be in parallel. Is there anything that we can say to be in parallel without having anything in between? So we look at that. We look at that particular block diagram, and then we talk about what is it that is in parallel. So we can also not say that G2 and H1 are in parallel because there is a pick-off point in between. So there is nothing in parallel. There is no complete loop, like we cannot reduce this loop because of those pick-off points in between. We can also not reduce that loop because of that pick-off point in between. And this one and that cannot also be said to be in parallel simply because there are some pick-off points in between. So what rule are we going to use? Maybe we can talk about this point here. We can talk about this point here. We can call it point 1. We can call that 1.1. So the easiest way to go about it is to move that particular pick-off point that we have named 1 so that it is ahead of block G2. So we are moving it from here to that. And you'll realize that block G2 was part of it. Block G2 was part of that. That signal was just after G2, and therefore if we move it to that, then what we need to do is that we are going to multiply by G2. And therefore, if we do that, then we are simply talking about moving this block from that point, moving that particular pick-off point from that. And if we do that, then our block diagram will become this. So we are going to have a block diagram where we have H2. We are going to have our H2, G2, then our block diagram will now be in that manner. So that is what we are going to have as our block diagram. So what is going to change is that because the pick-off point was initially at that point, then we have moved it at that, then we are going to multiply that particular loop by G2 because it was a signal that has been amplified by the forward element G2, and therefore we must include G2 in that. So that is the first step. Now, after doing that, after that step, one thing that we'll realize is that now we can combine. So we say that the first point was to move the pick-off point 1 ahead of block G2. So move pick-off point 1 ahead of block G2. So we move it from here to that. Then after you've done that, this is now going to be your block diagram that you have there. Then after you've done that, now we can see that of course there are still no blocks in series, But now we can see that there are blocks in parallel. That is G2 and H1. So we can use that in order to remove that. We can combine block H1 and G2 that are in parallel, and we have the block diagram. So the second thing that we are going to do is combining blocks H1 and G2, blocks G2 and H1 in parallel. So if we combine the two blocks that are in parallel, then we combine the two of them that are in parallel, then we are going to remove this summing point. And now that this one is not indicated, it means that they are all plus. So we indicate a plus there. So in that case, because there is nothing that is in between, we can have G2 plus H1. So here we can have G2 plus H1. And when we do that, the summation sign will be removed in that manner. So we have a block diagram after combining the blocks G2 and H1 in parallel. So that is the block diagram that we are going to have. So we are going to have a block diagram like that. So we can talk of G2 plus H1. Maybe we can talk of G2 plus H1. So here we can have block G2 plus H1. So that is now what we have. Again, we are still going to use the rules. We are going to use the rules repetitively until we come to a point where we have obtained what we refer to as the canonical block diagram. So in that case, we can look at this. If you look at this, you'll realize that there are some blocks that are now in series. There are blocks that are now in series, like this block is in series, this is in series with that. So the third thing that we are going to do is to combine. The third thing that we are going to do is to combine the blocks in series, combining the blocks in series. That is the blocks in series. Combining the blocks in series. That is, we are talking of G2, H1, and G3. So if we combine the blocks in series, then in this case, we are going to have this. So this one will now become one block. So we have G3 into G2 plus H1. So here we have G3 into G2 plus H1. That is now after combining the blocks in series. And again, we look at what other thing that what other rule are we going to apply in order to ensure that we reduce it until we reach the canonical form. So after doing that, then now we look at, is there any block in series? Do we have any block in parallel? We don't have any remaining in series. We don't have any remaining in parallel. There is no loop that we can reduce, because if we talk of this loop, then it means that that one there is a pick off point, so we cannot remove it. This loop, it's not even clear. We cannot see how even to remove it. So in that case, we have to move the pick off point again. So we can call this part point 2. So we are going to shift. Now in this case, we are going to shift the pick off point after the block. So shifting. So the fourth one here. The fourth one. Shifting the pick off point. Pick off point. Shifting the pick off point. So we are going to shift this point 2 so that it comes to that. So shifting the pick off point beyond the block G3 into G2 plus H1. So we are going to shift it beyond that block. So if we do that, this particular block, so it means that the signal will come here. So if the signal comes here, if this signal comes here, if it comes here, maybe we can't. Then this one was not there, so we are going to divide by that. So we are going to have, we can talk about, we can reorganize this, so that we have, this one was H3. I have H3 here. Can have H3 here. Then this, we can have it here, so that here we can have a bigger block, that is H2, G2 all over, G3 into G2 plus H1, so that is the new block that we have. Then of course, this is what we have modified, so we get rid of it. That is what we have modified. So that is what we have modified. So that is our new block diagram that we have in this case. So the next point is to eliminate the minor feedback loop H3. So number 5, eliminate the minor feedback loop H3. And if we eliminate the minor feedback loop H3, we are going to use the rule for elimination for the block, for the elimination of the loop. So in that case, we are going to use C of S over R of S will be given by G of S all over 1, that GH. And in this case, our G is G3 into G2H1, G2 plus H1 all over 1. Because the feedback is negative, it becomes positive. So it's going to be plus G, our G is again G3 into G2 plus H1. So that is our G times H. And what is our H? Times H3. So we can simply say that this is G3 H3. So with that, we can now, we have eliminated that. So in that case, we are going to have, and after doing that, the block diagram will become, so if we do that, this is our new block diagram. So after that, this is our new block diagram. After doing that, our new block diagram will now be this. Will be that. Then here. Then that way. Then here we have G3 into G2 plus H1 all over 1 plus G3 H3 into G2 plus H1. So that is going to be our new block diagram. So when we have that as our new block diagram, then we can now look into how are we going to, what is it that we are going to do further so that we can obtain, what rule are we going to use in order to get to move towards achieving our canonical form of the block diagram. So if we do that, if we continue with that, then in that case we are going to obtain, we reduce, again we eliminate that loop, eliminating the loop, the minor loop H2G2. If we eliminate the minor loop H2G2, then what are we going to obtain? So number 6, eliminating the minor loop. If we eliminate this particular minor loop, then what are we going to get? We are going to get C of S all over R of S will be given by our G is going to be G3 into G2 plus H1 all over 1 plus G3 H3 into G2 plus H1. So that is our G all over 1 plus GH. So our GH is going to be G3 into G2 plus H1 all over 1 plus G3 H3 into G2 plus H1. So, and then that one you multiply by H. Our H is H2 G2 all over G3 into G2 plus H1, of which if you do that, then this one and that one can cancel, and therefore what we are going to have, and then if you do your division properly, then this will also cancel, and therefore our C of S all over R of S in that case is going to be G3 into G2 plus H1 all over 1 plus 1 plus G3 H3 into G2 plus H1. So this one plus so this one will make a common denominator plus G2 H2. So what that one means is that now we have eliminated this, we have eliminated this, we have eliminated that, and if we have eliminated that, then now what we have here is going to be something of that kind. We have eliminated that, and if we have that, then what we have is going to be something of that kind. And you write all that, then we have G3 all over G3 into G2 plus H1 all over 1 plus G3 H3 into G2 plus H1 close the bracket plus G2 H2 G2 H2. So that is what we have after eliminating that particular loop. So we have that expression after eliminating that particular rule. After that, we can now see that we can combine the G1 and that one that are in series. So combining the blocks in series, number 7, combining blocks in series. You combine the blocks that are in series. So if you combine the blocks that are in series, our block diagram will now become, we just combining, multiplying that by that. So we are simply going to have our G1 here. So we can have that and then have our G1 there. So that G1 combines all that in series. So that G1 combines all that in series. So we can now what we can see is that we have a canonical block diagram. We have a canonical block diagram that is one forward element, and again we have one feedback element, and without anything on that feedback element, it means that the value of H, so this one simply means that the value of H is equals to 1. So if the value of H is equals to 1, then we can simply get, so we can create a space here. So what we have here is something like that, with the value of H equals to 1. Then now we can obtain the overall transfer function. We can now obtain the overall transfer function by eliminating the major loop that we are remaining with. So eliminating the loop, that is number 8. Eliminating the loop with the H is equals to 1. Eliminating the loop of H is equals to 1. Then from here we can now get Of course, using the rule, we can talk of C of S all over R of S is equals to G all over 1 that GH. And of course, what is our G? Our G is going to be the whole of that. So it's going to be G1, G3 into G2 plus H1 all over 1 plus G3 H3 into G2 plus H1 and then plus G2 plus G2 H2. So that is our G, and then this one is going to be over 1 plus GH. So that is the G. So that is going to be G1 G3 G1 G3 into G2 plus H1 G2 plus H1, then that one, so 1 plus GH. So of course all over 1 plus GH. The plus is because this is negative. Then GH, our G is 1 plus G3H3 into G2 plus H1, and that plus G2H2. So that is now what we have. If you simplify this, then of course, if you simplify that, then what we are going to get for this if we simplify that, then we are going to get our C of S all over R of S is going to be the G. It's going to be G1 G3 into G2 plus H1 all over 1 plus G3H3 into G2 Of course, this one you must multiply by 1 because H is equals to 1. G2 1 plus G3H3 into G2 plus H1. G2 plus H1, close the bracket, plus G2H2. Then, because this one we add 1, that is going to be multiplied by that. Then, this one, then plus G3H3 into G2 plus H1 into G2 plus H1. That is now what you have in that case, and that is now the expression that you are going to have. Of course, this one and that one can be 2, you can have them as 2 G2H3, or you can just express it that way. This one and that one, if you look at them, they are, if you combine them, it is 2, because that is 1, they are the same. So that is 2 of that. So you can simply say that C of S all over R of S can be simply be given simply as G1 G3 into G2 plus H1 all over 1 plus G2 H2 plus 2 G3 H3 into G2 plus H1. So that is now the overall transfer function. So you can have that one as your overall transfer function, of which now you can conclude the block diagram by simply having this, so that you have your C of S, and it gets into that block, the big block, and that one now is going to be G1 G3 into G2 plus H1, then all over 1 plus G2 H2 plus 2 G3 H3 into G2 plus H1. Then that is now what you have as your transfer function. So that is how to obtain the transfer function. So if maybe somebody asks you to obtain the open loop transfer function, then it will just be G times H, and in this case H is 1, so it will just be this 1 times 1, which will still remain this. If you are asked of the error ratio, just apply the formula for the error ratio after, and that one must be done. Any ratio that you are supposed to obtain, it must be done after obtaining a canonical block diagram. It is the canonical block diagram. It is from the canonical block diagram that you can obtain the various ratios that we talked about, be it the error ratio, be it the primary feedback ratio, or whether it is the control ratio or the closed loop transfer function, as far as that is concerned. So that is at the end of that particular example. So that is what we can have.